It's running. Great. Okay. So today we're going to talk about docstring testing. So somehow since the beginning of term I've been diligently writing these type of docstrings when I wrote any type of function. And to be honest with you, I didn't actually know that this did anything. I just thought this was some like fun notation that we were giving you guys to get you used to writing tests. But it turns out this is useful, right? You can actually run this through a doc test. So I'm going to show you how to run Doctests today. So here's a factorial function. Let's write it. Okay, so where am I? What day is it today? Tuesday? Let's code this up. Okay, so I'm just going to define a factorial function. Does everyone know what the factorial does? Yes. Yes, but is there anyone in here who doesn't know what the factorial is? You don't know what the factorial is? Good. You get 10 extra marks for being honest. If you don't know what something is, tell the professor, otherwise you'll never learn. Okay, the factorial is this, right? So k factorial is k times k minus 1 times k minus 2 all the way down to 1, right? So I can say the factorial of 3 should be what? 3 times 2 times 1, which is 6. What about the factorial of 0? 1. Why?
It's a convention when you have special product or exponent operations.
Stop saying convention. Just say, because we're mathematicians and we say so. Because I say so. All right? That's the reason, right? We had to set factorial of 0 to something. Right? The real reason is that it conforms to the pattern, right? 1 factorial should be 1 times 0 factorial. In fact, everything is going to end with a 0 factorial, right? So if we set 0 factorial as 0, every factorial would be 0. So we're sort of obligated to set 0 factorial to 1. That's the same reason anything to the power of 0 is 1 as well, right? It's so that when we write a recursive statement, there has to be some sensible base case. And the sensible base case for 0 factorial is 1, right? But it's fun. If you guys become mathematicians, you get to learn that you guys get to make the rules of mathematics. That like, it's not like physics where we have to go and like follow the rules of the universe. Like we create the rules of the universe. It's quite fun. Okay, so I'm going to write this factorial function. I'm going to write an accumulator here. I'm going to say 4k in range. Oh, I can't use that again. Have you guys seen this before? L? Okay, so look at this. This is 1. This is L, right? It's generally a convention among computer programmers to never use the variable L because it looks way too much like 1. But sometimes you want to use the letter L. That's why we spell it out, right? This is L. So you'd have something like I, J, K, L. Do any of you know what LaTeX is? Okay, well this gives you loopy L, if you care to know. Okay, I'm just going to accumulate on answer here, and then return the answer. Okay, so I'm going to show you how to run these doc tests now. Okay, so I can call this into Python. I can take the factorial. I can now do, oh, it's maybe a little bit too small. Okay, I'm going to do this. Import doc testing, and then doctest dot testmod. Right, test the module. Someone have the hiccups, or someone have a question? Hiccups and question? No, it's okay. I'll know to ignore you. But before I hit this, can you study this code and tell me what's going to happen? Okay, I'm going to start giving you more problems of the line. There's a bug in this code. Find the bug and fix it. Because if you ever go work in like for a company, that's like 90% of your job is fixing other people's bugs. Which is why you're going to start having strong opinions about sensible variable naming and documentation. Yeah. This fellow. You, yes.
Yeah, I think the range should be a plus 1. For example, like for L goes from 1 to...
So like this?
Yeah, I think so.
Everyone agree? So if I run this doc test, both of these tests will pass? No, why?
Because if you enter in 0, it'll have no arguments whatsoever. So
If I enter in 0, it's going to set answer to 1, skip the for loop, and return 1. That seems right to me, right? Yeah.
Is anything going to happen to the string that's above the first, like the fact string? Is that going to do anything, or is that just a comment?
Nope, that's going to be fine. So ignore that. Yeah. He has it. What's the first thing in range? So what's my answer going to be in every case? That's correct. True story. I implemented this incorrectly, right, when I did it a few nights ago. And my Docstring testing actually saved me, right, because it said you failed all test cases. I'm like, because I would never write the factorial like this, right, with a loop. I'd write it recursively, which I wish I could show you more recursion, but I guess we have to wait. Okay, so let's leave and bring this back in. Okay, so I'm going to import the doc testing now. Now I'm going to say doctest, whoops, yeah, doctest dot test my modules, or test my functions. And it's going to say you failed none of them and you attempted 2 of them, right? So we passed both of these tests. If you want to see, do you guys know what it means to be verbose? It means you use way too many words than necessary, right? You use 10 words when 1 word would suffice. It's someone who's very wordy and likes talking, like all of your professors, for example. But you can tell basically functions to be wordy. Like a lot of functions have this verbose equals true option, which just instructs the function to print information, right, that usually you wouldn't want. So here you go. This is the information of the docstring test. It's saying trying factorial of 3, I'm expecting a 6, and I got a 6. Okay. Trying factorial of 0, expecting 1, got a 1. Okay. Let me introduce my mistake again. Oops, that was too far. And let me just call this in. Okay, so there's a mistake in this function. So let's import doctest dot testmod. And now it has printed something, but only the tests that have failed, right? So like this is generally speaking the behavior that you want, right? You want to run a test and see nothing basically if your tests succeed. But if your tests fail, you want to see which inputs it has failed on, right? So introducing my old error, it's saying that factorial of 3, I was expecting 6 and I got a 0, right? So that test failed, okay? So here's a little bit about the mechanics of testing, right? So immediately you can just call in this doctest library and test your modules, right? All the docstring tests that you wrote, provided they're correct and written correctly, can be sent through this doctest module. Okay, that's the factorial. There's errors in it. I've shown you this, and here's the corrected version. Okay, so really, the point of today's lesson is not for me to show you how to use the doctest tool. That was easy. That's one function call. But to figure out how to write good doc tests in the first place. Right? So we're going to do a series of exercises to try to figure out what good practices are. But doc test writing, or writing good tests, is like a skill. It's a skill. Like you can get, if you look through Indeed, you may see job postings for QA analyst, quality assurance analyst. And sometimes, or often, it is the case that these QA analysts are people who are hired specifically to write test cases for systems. Right? So writing good test cases is a skill that you need to develop. And if it's a skill that you develop to an expert degree, you can get a job specifically in testing, right? So don't take this for granted. This could be hard. So I can't give you like hard and fast rules for doc test writing, but I can give you some guidelines that should be good. Is that too bright? You guys can see this? Let me see if I can dim the lights. So number one should be a little bit obvious, right? Your test case should include a typical example, right? So for my factorial, this is a typical example. You may want to take the factorial of 3. Right? So it was good to include that. You want to include an edge case. In this case, for factorial, an edge case was 0, right? Because something special happens at 0. So you want to make a test case for every special instance that your function may have. You want to test the zeros of the data type. So in my factorial example, it happened to be the case that one of the edge cases was also a 0. But it is usually the case that the 0 or the empty type is an edge case. Right? So when I say 0, I mean literally 0 for numbers, like integers and floats. But I mean the thing that sort of acts as 0 in the data type. So an empty list would be the 0 for lists, right? It's the list that you can add to any other list, which leaves that list alone, right? That's basically the property of 0, right? That when you add 0 to something, the thing that you're adding to doesn't change, right? So you want to try your zeros and empty lists. Do you guys know what a singleton is? This is a special name for a list that has exactly one element, right? So you want to usually test the empty list, a list with exactly one element, because sometimes those can like really mess up your programs. The best doc tests ensure that every single line of code in your function gets executed at least once, right? Specifically if statements. Every if statement should be triggered in one of your doc tests. Otherwise, there's pieces of code that are like not tested at all, not even run. Right? So you want to make sure that everything that can happen in your code does happen in your code, and in addition to that is tested for. Remember, I keep talking about correctness. That is, a correct function gives you what the contract says it's going to give you, given the things the contract is expecting. Right? So again, I'm trying to get you guys away from thinking about type checking. Type checking is the very, very last step. It's done by an intern. Right? So when you're doing docstring testing, I don't want to see 100 tests that are like, oh, took an A but was expecting an integer. Right? Took a list but was expecting an integer. Don't doc test type checking. Right? Doc test things that are contractually allowed. Right? Otherwise, these doc tests are going to be thousands of lines long, right? We care about correctness and not some like technical correctness that this is going to throw errors when it should be throwing errors. And a good doc test should not have redundant tests. Okay, so I'm going to go back to my factorial example now. Okay, are these tests redundant?
No, you said so yourself. You have case testing for edge cases and case testing for typical. So you have one typical case and one edge case, which is also your 0.
Yeah, your evidence that I said it myself was strong evidence.
Yes.
What happens if I put the factorial of 6 in here, even though I don't know what it is? Okay, I'll put 4. 24? Is there now redundancies? Yeah, is there really any functional difference between testing factorial of 3 and testing factorial of 4? Like, how many of the individual cases should we test? Like, at some point, if factorial of 4 is working, especially in this example, if factorial of 4 is working, factorial of 3 is working, right? Factorial of 100 is working. Why isn't this a good test? I was not expecting that. Wow, that wasn't that great. The internet was a mistake. Okay, who cares? Why would this be a bad example?
It takes too long.
Yeah, you don't want to have to wait around days for your doc test to complete. Now, it may be the case that you're doing scientific computing, And you need to know that like my functions still work when I give it like the largest possible integer. But you guys aren't there yet. I find it so cute when you guys ask me if you're going to get marked down for code inefficiency. I laugh. Inefficiency. We're just worried that you guys are writing any type of correct code. Efficiency comes later, but it tickles me that you guys think that you're there. Anyways. Do you think this is a good enough test case for these? Yeah.
I want to start testing with one case even, so make sure that 0 factorial still is.
Yeah, that's actually a really good idea in this case because if I input 0, does line 15 or 16 execute? Okay, more specifically, if I input 0, does line 16 ever execute? No. So we actually need the other edge case. We need an edge case which gets us into the loop, but like is the smallest example. So factorial of 1 would also be great. That's considered 2 edge cases. Okay. I'm going to write a power function like x to the power of something, which returns a float and accepts floats. And I'm going to write it in such a way that you're not going to understand it. Right? I'm going to write it recursively. Maybe some of you will understand it. But I'm going to write it recursively in the hopes that most of you want to understand the code so that afterwards you can try to like break my code, right? To see that it's working, right? And this is basically how you come up with test cases by saying, how can I break this code? Okay, so power. If y is 0, return 1. If y is negative, return 1 over power x to the minus y. If x is negative, return minus 1 to the... Oh, no, I don't have to do that. Let me think. I'll come back to that. We want to return x times x minus power of x minus 1. Oh, x and y minus 1. Right. I think this should work. Oh, but that's actually the point of this exercise. Okay. So let me call in my power function. See. Oh, what am I doing? Okay, so I'm just going to check a couple. Okay. So there's a function that I wrote. Okay? Maybe most of you don't even believe that this should work. That's usually the feeling among my students when they see their first recursive function. It doesn't work. And I'm like, no, it works because of magic. So this is the real, now I'm going to hand over this function to you. And suppose that you're running some like mission critical program. Like your software runs like the space shuttle. And if there's any arithmetic errors in that, like the shuttle is going to explode. So like the stakes are high, right? What test cases would you be comfortable writing so that if the function passed all the test cases, you'd be confident that this function is working correctly? Yeah.
When you call power recursively inside your power function, is the power function that's running the built-in function?
I shouldn't even be showing you that this has contents. Like imagine this is black box. Like imagine you can't see this. Right? Don't get distracted from like what we're trying to do here. Right? We're trying to test this function. Who cares how it works? Right? In fact, pretend you can't see it. I don't know how to get, can I get rid of it? No, I get rid of too much. But I can do this, at least. Anyways, just pretend it doesn't exist. Okay? And let's write some, I'm going to just throw that down there. Does not exist. Okay, so let's write some test cases so that we have so many test cases that when it passes, we're confident that this function is working. Yes? Hit me.
Wouldn't it be that you go power of, let's just say 5 to 0? Like, when you try to put something to the power of 0?
Why not? 5 to the power of 0. That should be 1. And this is a edge case, I guess. Yeah, what do you want?
0 to the power of 0.
0 to the power of 0. What should that be?
I have no idea.
should be 1. Anything to the power of 0 is 1. Even 0 itself. Okay. Shh. So this is enough? You'd be comfortable launching your space shuttle and watching it explode in the air? Yeah. Yes. 0 to the power of 2 should be what? 0. Yes.
5 to the power negative 1.
Finally, some negatives introduced. That should give you what?
1 over 5.
Nope. Actually, I think all of these are already wrong. Right? I'll tell you, like, spoiler alert, docstring testing is only testing strings and not values. Right? So today we're actually talking about docstring testing. Friday we're going to be talking about unit testing, which is testing value. So in a unit test, it doesn't matter if you say 1 or 1.0, because integer 1 is equal to float 1. But with string testing, it will matter, and I'll show you some of those nuances in a bit. Yes? Negative x? No, you can't put, we can't use x in our computations. Okay? You can't just take x squared, right? Python's going to say you can't, like you need to define x.
No, I'm saying, for example, like -2 or like bracket -2, because I know how those have different figures.
Oh, sure, you want to try -2 to what?
So like, power
3
should be -8.
should be -8, 0.0.
But then if you do like, for example, -2 to the power 2 with no brackets, you should be getting -4.
Well, it depends on the order of casting, and I don't think you're right. Doesn't the negation cast first?
I thought negative, because if it's not bracketed, it's
I'll give it a try. Oh, you're right. You're right. So,
No, but you did. Wait, no, since the negative is like try the default power function.
no, exponents are happening before the negation. Very clear, right?
That's
That was the argument.
right. That's
Yeah.
That's when you do it inside the actual like that's the operation. That when you do it in the power function, there's a built-in power function in Python.
Yeah.
It does before.
Well, we'll have to come back to that one. So this should be -8. That's it? This all you guys want? Yeah.
We didn't do decimal cases.
Yeah, you didn't do any of the float cases.
A half to the power of 2.
Is that 0.25 or 2.5?
0 to 5. 3 to the power of the borders. This is 0.75.
Yeah, so my code doesn't actually handle this case. So you finally broke the code, right? My code can't do float powers. All right, do you know what I would need to do in order to get float powers now?
Import library.
That is technically the correct solution for a lazy programmer, but which algorithm? No, you learned it. You all know it. Yeah.
Is it Newton's?
Newton's algorithm, or what is it called? Newton's iteration? I'm sure you guys all know, okay, you all know a strategy of finding the root of a polynomial, where a root of a polynomial is where it crosses the y equals 0, like the x-axis. So you know some procedure, which is like, go to an arbitrary point on your function, find the tangent line, see where the tangent line hits the x-axis, move to there, go back to the curve, and repeat this process. Right? If I search Newton's iteration, and what's his name shows up, right? I should just come in here and play like YouTube videos for you guys. Is this an animation? GIF? Yeah. Ta-da! See? So maybe I can get you guys to write this. But you can program Newton's iteration to solve the equation. So suppose I wanted to find the square root of 2. You could solve the equation x squared minus 2 using Newton's iteration. And in fact, Newton's iteration is going to numerically iterate towards the square root of 2. How did you think your calculator was doing any of this? Right, when you hit the square root of 3 button, do you think there's a giant table where it has like memorized all of the square root 2 of every number? And this would also be a good assignment where I get you to program like the functionality of a basic calculator. Because even this gets sort of weird, right? So anyways, so we can do this. So let's see how many test cases I actually pass here. I'm actually curious. So how many do you think I can get? I think I can get everyone but this one. Well, I know I'm not gonna be able to do those ones. 3 to the power of 0.75. That should be this. So let's get out. Let's go in. Let's import the doc test. Let's do the doc test. And let's see what happens. Which ones? Oh my god, I failed a lot. Expected 1.0 and got 1. Okay, so there's some... I should cast maybe my answer. Okay, let's try again. I failed 2? So power of minus 2 to, 8.0. Okay. Oh, there's a syntax error here. Oh boy. Okay, I know what happened, right? I entered an infinite loop. Right, because Anyways, I don't want to explain this function too much because the reason I wrote it is because I was hoping you guys wouldn't understand it. Suffice it to say, we cannot be confident that this function works, right? Because it doesn't pass all of these test cases and it should. Let's just go through here to make sure that there's nothing redundant and then we can move on. Do you see anything in here that may be redundant? Maybe, but like... Oh, you're right. Yeah, these two are... I think these two... Because by the time -2 gets to power, like the one with the brackets have been dropped. Right, so I guess this one is redundant. Anything else? Nope. But like, let's just finish this off, like the test cases, knowing that they can't finish. Right, because I want to make sure that we got one of everything. So like, this is what we really need. We need an integer, a negative integer, a float, a negative float, and a 0 in the first position. And we need all of that stuff in the second position, and then we need all of the cross interactions between those to really get a comprehensive set of test cases. So I guess that would be, what did I say? Integer, negative integer, 0, float, negative float, 5. So 25 test cases? Yeah, I don't want to write 25 test cases, right? But these test modules can get huge, right? I've worked on projects where like the test files were like gigabytes of size. Well, I was doing scientific computing, right? So we had big data types, but still, testing is important. So what we were doing just now was called the black box approach. This is somehow, what else can I call this? It's also called the adversary approach. Like, ideally, you should give your function to your friend to write doc tests for. And like the philosophy that you should take is, I hate my friend, let's try to break his toy, right? Just try to break each other's functions. And like by doing so, you're going to come up with really good doc tests, right? Because that's the philosophy you need. How can I get this function to break, right? A black box is basically a function whose code is hidden from you, right? So this is also another good way of doing black box testing. Just assume you can't see the code and ask yourself, how many evaluations of this black box do I need to gain enough confidence that this code is working? Okay? Because you're never really going to be able to come up with definitive proof that something's working in all cases. Like, computers are fickle beasts, right? Weird things can happen, memory leaks and stuff like that. So just because something's passing all your tests doesn't necessarily mean that it's working in all cases, but it's a good start. It is actually possible to mathematically prove code works, but you guys are years off. Okay, so I mentioned this before. What we're doing is not unit testing. What we're doing is string testing, which means it's not comparing values, right? When factorial of 3 spit back 6.0, the doc test was doing a string test. It was testing that, where's my terminal? Okay. Right, in that case, something that like 6.0 was equal to 6.0. Jesus, Murphy. Okay? That's why it rejected this, right? Even though it is the case that these are equal, right? So in a unit test, 6 is equal to 6.0. But in a string test, 6 is not equal to 6.0. Right? So a string test really tests string output and unit tests test values. So because we're comparing strings, this function is going to fail all of its tests. Right? So I'm just going to grab this. Okay? And this function could not be more simple. It's just, I don't know why that's there. Okay? It's a function which just returns the thing that it's given. Right? It's almost impossible that this function could have errors in it because it's doing so little. But nonetheless, I'm going to run this through the doc tester, and you're going to find it's going to fail all of its cases. Tuesday? Ugh. What has happened? Okay, so I have some identity function which just takes this or takes this and returns something. Okay, 1, 2, 3. I'm going to run the doc tester. Everything failed. Why? Oh, actually, not everything failed. I meant to do this, right? Yep.
There's on the Docstring, there's one where the answer is on the same line as the function.
Whoops. Let's try that again. Okay, now all tests have failed. Can you see why? It's expecting literally square left brace space square right brace, right? And notice that this string is not equal to this string, even though this list is equal to, I think this is correct. Yeah, true. Okay? So we're string testing and not unit testing. So how can I correct this so that all tests will pass? Yeah?
Write it in the exact same format as the...
Okay, but elaborate. How do I fix line 4?
And like delete the space inside that and add the spaces after it every time.
Now we've passed all tests, right? So like in terms of values, we haven't changed anything, but in terms of strings, we have, right? So be careful with white space in particular. I think even this would screw you. Yeah, even this tailing space here screws you, okay? So this is why I would encourage you to set your IDEs to actually display hidden characters. Right, because now hidden characters are getting really relevant, right? So just be careful that the output from this has to be exactly as it's written here, right? So if you want, you can write docstring tests by just going into here, typing some stuff out, right? And you'll always just be able to do this. But that's not, sort of violates the whole principle of docstring testing, right? You want to write docstrings before you write your function to ensure that your function is working once written. This is sort of circular logic. Okay, other stuff that you can do. You can actually do Python stuff up here, right? Whoops. Right. So all that stuff gets actually executed by Python. Right? So if you wanted to write some more sophisticated doctests, where you wanted to do like multi-line type of definitions, you can do that. Right. How much time do I got left? 10 minutes. Do you guys have tests today? No? Okay. Okay, let's just finish off today's lecture by talking about tests, but let me talk about this question before you go. So this question is on the lab this week. I wrote the lab this week, so if it seems more mathematical than it usually is, it's because I'm a mathematician, so now you guys have to suffer along with me. But you guys remember finding maximum and minima of polynomial in high school? I hope you do. Well, I know it's surely the case that all of you are enrolled in calculus. Yes. Okay, so if I gave you a parabola, what does it mean to find a critical point on a parabola?
Finding the root of the derivative.
That's technically what it means to, but like what have you found if I found the critical point?
When the derivative is 0 or something?
Yes, that is true. But like specifically talking about trying to find local extrema. Yeah. Someone must have the answer. All of these things are correct that you're saying, but not quite there yet. Yeah, yeah. Okay, okay, one more guess and then I'm just going to tell you the answer. You back there with the glasses. Yeah. Huh? Okay, you guys are going to make me do the thing I had to do for the other class. Okay. Parabolas can look one of two ways, right? Where's the critical point? Here, right at the turning point. So, everything you said is correct. If I find a critical point, I found the part of the function which is flat or which it turns. The answer I was looking for in terms of extrema is that on a parabola, the critical point is either the global minima or the global maxima, right? It has to be one or the other, right? Because like the parabola has exactly one critical point and it tells you about its global properties. So in the lab, I've coded a function that says something like this, like given a parabola and an interval, find the largest value of the parabola over that interval, right? And this is why sort of it's a trickier problem, right? So here's a parabola. Did I say minimum or maximum? Minimum. Right, so over this interval, here's the minimum. Right? I could draw another one like this, like just a regular parabola, and then I could restrict the interval to here. And then this would be the minimum. Right? So I've given you a problem where you take in a bunch of coefficients. You take in A, B, and C, the coefficients from a polynomial, and an interval with a left endpoint and a right endpoint. And I want the function to return the minimum value of the polynomial. Now, I wrote some code that does this for the lab. The code is wrong for a bunch of reasons. So I want you to figure out why it's wrong and complete it and write docstring tests. For example, if you're taking in A, B, and C as coefficients, what happens if A is 0? Yeah. Yeah, and therefore everything I just said isn't true, right? So if I like implemented something for finding a minimum on a parabola, and you send me a line, my function no longer works because its operating assumption has changed, right? So in particular, I never told my function what to do in the case of a line or a constant, right? So there's a lot of edge cases that you can find with this problem. So I want you to think about it a bit and try coding it. It's like the hardest code is already there. I just need you to put in the code for the line. Maybe that's enough for today. The only thing I wanted to mention, we'll discuss it on Friday. Why don't you guys get out of here? Yeah.